something about chromatography in forensic and legal field. Chromatography, although primarily a separation technique, is mostly employed in chemical analysis. Nevertheless, to a limited extent, it is also used for preparative purposes, particularly for the isolation of relatively small amount of material that have comparatively high intrinsic value. Chromatography is probably the most powerful and versatile technique available to the modern analyst. In a single-step process, it can separate a mixture into its individual components and simultaneously provide a quantitative estimate of each constituent. Sample may be gaseous, liquid or solid in nature, and can range in complexity from a simple blend of two enantiomers to a multi-component mixture containing widely different chemical species. Furthermore, the analysis can be carried out at one extreme on a very costly and complex instrument, and at the other on the simple, inexpensive, thin layer plate.
Hello, my name is Liza. So now I will explain about the theory behind our topic. But before discussing the forensics application, let's first understand what chromatography is. So chromatography is an analytical technique used to separate the components of a mixture. It consists of two phases, which are the mobile phase and the stationary phase. The mobile phase can be a liquid or a gas. Its function is to carry the sample through the stationary phase. Meanwhile, the stationary phase is the fixed material where separation takes place. So, as the sample moves to the stationary phase, each compound interacts differently with both phases. So, because of this different interaction, some compounds travel faster, while others move more slowly. As a result, the compounds become separated from one another. For example, in paper chromatography, this separation can be observed as distinct spots on the paper. You can see the example on the image that I already provided here. So now that we understand the basic concept of chromatography, so next let's see how this separation actually happens. To better understand the separation process, let's use paper chromatography as an example. So in paper chromatography, the paper acts as the stationary phase, while the solvent acts as the mobile phase. So the sample is first placed on the origin line. Once the paper is placed into the solvent moves upward through the paper by capillary action, carrying the sample along with it. However, not all compounds travel at the same speed. Now let's take a look on this animation. So, as you can see, the compounds move at different speeds. This is because different compounds have different polarities. Compounds that have a stronger interaction with the stationary phase tend to move more slowly and therefore travel a shorter distance. On the other hand, compounds that have a stronger interaction with the mobile phase will move faster and travel a longer distance. As a result, each compound reaches a different position on the paper, producing distinct spots and successfully separating the mixture. In addition, although chromatography can also separate compounds based on molecular size and affinity, polarity is the main factor illustrated in paper chromatography, which is why it is used to explain the basic separation principle. So the same separation principle is applied in modern forensic laboratories, but with more advanced instruments such as gas chromatography and high-performance liquid chromatography. So we will discuss about this next. So in forensic laboratories, the two most commonly used chromatographic techniques are gas chromatography or GC and high-performance liquid chromatography, that also known as HPLC. So, gas chromatography is suitable for analyzing volatile and thermally stable compounds such as alcohol, illicit drugs, and fire accelerants. HPLC, on the other hand, is used for non-volatile and thermally unstable compounds such as poison, pharmaceuticals, and certain drugs. So, to improve the accuracy of the analysis, both techniques are often combined with mass spectrometry, forming GCMS and LCMS system. So in these systems, chromatography first separates the compounds, while the mass spectrometer identifies each compound based on its unique mass spectrum. So this combination provides highly accurate and reliable results, making GCMS and LCMS valuable analytical tools in forensic investigation and legal evidence analysis.
How do chromatography is utilized in the forensic and legal field? Forensic scientists will compare the ink on suspicious contract, will, or ransom note. This will prove whether the document was altered, forged, or signed with different pen. For the method, firstly, we could use TLC. Ink is poured into a stationary paste, such as a silica gel plate, and a mobile paste, which is a solvent. Draw the dye components outward. Dye will separate into distinct measurable bands. Meanwhile, for HPLC, a more advanced, highly sensitive technique used to quantitatively separate and analyze the precise chemical formulas of dye mixture. Lastly, for gas chromatography, it specifically used to separate and identify the volatile solvent and organic compound like phenol C external within an ink base, which is crucial for determining how long ago a document was signed.
Another example of how chromatography is being utilized is under the toxicology and drug analysis part, where chromatography helps to detect whether someone is under the influence of drugs or not, and they can also determine the cause of death of someone, whether they died due to overdose or homicide cause. The way they determine this is through the gas chromatography and HPLC. My name is Shafena, and I'm going to share steps involved in drug analysis using gas chromatography, mass spectrometry, GCMS. The first step is sample collection, where we can get our sample from the crime scene or from the individual itself. The second step is preparation of the sample. After we already prepare our sample, we will inject small portion of our sample into the gas chromatography. In this gas chromatography, the sample will be vaporized and then the compound will be separated. This separated compound will go inside the mass spectrometry, and the compound will be ionized into charged fragments, where they will be separated according to their mass to charge ratio, and a unique mass spectrum will produce. This unique mass spectrum will be compared to standard reference database so that we can identify the substance. Last step is the interpretation and reporting. Forensic analysis will interpret the retention time from gas chromatography and mass spectral data from the mass spectrometry. After that, they will document it and present the data as evidence in court proceeding.
Initially, chromatographic technique were used to separate substances based on their color, as was the case with herbal pigments. With time, its application area was extended considerably. Nowadays, chromatography is accepted as an extremely sensitive and effective separation method. Needless to say, chromatography has proven to have a crucial role not only in forensic but also in food industry, drug discovery and development, molecular biology studies, and more. It may be concluded that the forensic science is incomplete without chromatographic techniques. Using sophisticated techniques, experts can unravel the mystery hidden in the ink, providing crucial elements for understanding criminal investigation. Constantly evolving, this discipline continues to play a vital role in the quest for the truth within the justice system.